Hi guys, welcome to another maths tutorial brought to you by Direct Tutoring. Today we're going to have a look at the 2019 past paper, paper 2, so this is the calculator paper. Now we've done the non-calculator paper tutorial and I'll put a link in the description to that. So without further ado, let's take a look at the 2019 calculator paper. So again, we get our formula sheet that we can come back to at any point within the exam. So we have a total of 60 marks, and what you tend to find is that the calculator paper tends to have more problem solving than the non-calculator. So we'll take each question nice and slowly and we'll see how to answer them in great detail. So question number 1 here says we have a charity that distributes 80,000 emergency packages during 2018, and this number is expected to rise by 15% each year. We need to calculate how many emergency packages the charity will expect to distribute in the year 2021. So what this is this is essentially compound interest, because what we have here is we have a percentage increase every year over an extended period of time. So the first thing that we'll work out is what we would class as a scale factor in order to express the increase of the percent in decimal form. So what we'll do is we'll say that we have 100%, so 100% plus, because we're increasing by 15% each year. So that would tell us that we have 115%. Now, in order to use this in the compound interest, we must convert this to a decimal. So the way that we do that is we just divide by 100%. So what that will give us is a value of 1.15. So that means, because any value bigger than 1, when we multiply it by any other value, we will expect a number bigger than what we started with. Whereas a value less than 1, we will decrease the value. So now that we know what our scale factor is, we now need to turn our attention to the number of years. So from 2018 to 2021, we can see that that's a total of 3 years. So the way that we would do this is we would say that the final value, or you can call this whatever you want, is going to be the original value. So that will be the 80,000. So that will be 80,000 multiplied by the percent scale factor in decimal form. So it's going to be 1.15. Now the power is the number of years. So this time we'll have to the power 3. So when you pop that into the calculator, you will get a value of 121,670 emergency packages that is expected to be given out in the year 2021. Now you get a mark for the decimalisation, we get a mark for substitution into the formula, and then we get the final mark is from actually putting this into the calculator and getting the final answer. Now question number 2 is a vectors question, and it asks us here to determine the magnitude of this vector p. Now the magnitude of any vector, these two lines will, if it didn't say magnitude, then these two lines denote magnitude. And the key thing with the magnitude is that the value will always have to be positive. And it's essentially a rendition of Pythagoras, because what we say here is that the magnitude of any vector, this is the general formula, would be the x coordinate squared plus the y coordinate squared plus the z coordinate squared. So now all we have to do is substitute in our values for the x, which is 6, so we'll have 6 squared, plus then it will be 27 squared, plus and then minus 18 squared. So when we pop that into the calculator, what we will end up with is 33. So that tells us that the magnitude of this vector p is 33. Now you can clearly see that the magnitude will always be a positive quantity because we square all these coordinates. So even if we have a negative value, when we square it, the negative will cancel itself out. So if you get a negative at some point here, in fact underneath the square root sign, then go back and check that you've substituted into the calculator correctly, because you cannot do the square root of a negative value. So now number 3 is, this is now the area of a triangle. So what we need to do here is we can consult our formula sheet again, because the area of the triangle that we need to use will be this one here. It can't be the standard 1/2 times the breadth times the height, because we don't have a complete standardized triangle. What we have here is a triangle that has irregular angles. So what we need to do here is we will write the general formula. So it will be A equals 1/2 AB times sine capital C. Now we should be familiar with the fact that capital letters will denote angles and lowercase letters will denote sides. So what we need to do here is, the best thing would be to label our triangle prior to substitution into this equation. This is good habit and good practice, especially when you come across the sine rule and the cosine rule. So remember that the side completely opposite is like the corresponding angle. So say here, this has to be C. This is capital C in here, right? So that's capital C, which means the line directly across from it is small c. So that means this would be small a and this would be small b. Now these are interchangeable. It doesn't matter which one is which. But when we, if we were looking at the cosine and the sine rule, then what we would have is that this small a, this would be capital A. This would be the angle directly opposite. So that's just something to note for when we come maybe to some harder problems later on. Now all we need to do here is substitute into the equation and then you just pop it into the calculator. So we have 1/2 multiplied by a, which we made was 45, so that'll be 45, times 70, multiplied by sine, and it will be 129 degrees. So what we end up with if we perform this calculation is we will get a value of 1224.004. Now because this is such a small decimal, I would round this to the nearest whole value. So we would say that the area is 1224 centimetres squared. You must remember the units. And the way that we can see where these units come from is that the 45 brings with it centimetres, and when we multiply it by the other centimetres, we get centimetres squared. So that's how you would solve that problem there. Now question number 4 gives us a sesame seed that weighs 3.6 times 10 to the minus 6 kilograms, and the weight of a poppy seed is 8% that of the weight of a sesame seed. We need to calculate the weight of a poppy seed in kilograms, and we need to give our answer in scientific notation. So what we're saying here is that one sesame seed weighs 3.6 times 10 to the minus 6 kilograms. So what I'm going to do here is I'm going to put weight for W and I'm going to put number, okay? And what we'll say here is that the weight, so we'll say that 3.6 times 10 to the minus 6 is equivalent to the weight of one sesame seed. Now, we know the relationship between a poppy seed and a sesame seed. So what that means is that the weight of a poppy seed is only 8% that of the weight of a sesame seed. So say this is 1 sesame seed, then if we multiply this by 8%, i.e. we would say that the weight of 1, or the number that we are going to put here, is going to be 1 multiplied by 0.08. So we would then pop this value in here. So we would have 0.08, and then what we're going to do is, I'll change the colour, we're going to perform this calculation. We're going to do 3.6 times 10 to the minus 6 multiplied by 0.08, and then we divide by 1, and that will give us this value here. So the calculation becomes 3.6 times 10 to the minus 6 multiplied by 0.08, all divided by 1. So our answer becomes, in scientific notation, 2.88 times 10 to the minus 7, and it will be kilograms. And we can always check that that looks correct, because if we multiplied this by 8, then we would see that this value for the poppy seed would be greater than that of the weight of a sesame seed. Now that can't be the case, because a poppy seed is only 8% the weight of a sesame seed. So that means that it must be considerably smaller. And we can see that because the poppy seed is a factor of 10 smaller than the sesame seed. So that's just a check that you can do to make sure that your answer is within an acceptable range. Now, question number 5 is, it gives us a diagram of a cone, and it tells us that the diameter of the cone is 6 units with a height of 8 units. Now the x-axis and the y-axis are tangents to the base, and A is the point of contact between the base and the x-axis, so that's this point here, and B is directly above the centre of the base. And we need to write down the coordinates of both A and B. Now we can do this by identifying the extremes of the shape, because if we know what the extreme values are, then it's very easy to deduce, because these are, say, in symmetrical terms, and they're also in key points of the geometry. So we know that from this point here, diameter wise, to this point here, is a value of 6. And we know that this would be the same replicated in the y-axis, so this value would be 6. Now we then know that the height, so from B, this is in the z-axis, we know that the height of the system would be 8. So now all we need to do is we can deduce what the values of the x, y and z coordinates are. So we'll start off with A, and we'll say, what is the x value? Well, we can see that it is halfway between the origin and the maximum diameter of 6. So what we could say here is that this is going to be 3. Now, we know it lies on the x-axis, so that means the y value, we don't actually go into the y value at all. So that would suggest that the y coordinate is 0, and because we're still on the x-plane, we have not actually risen in the z-axis. So we have another value of 0. So the a coordinate would be 3, 0, 0. Then for the b coordinate, we do exactly the same. But this time, we can see that B is directly in the middle. So even if we were to follow this, so this is the point that we'll look at to start with, because that's going to consider the x and y axis first. So we know that this will go along the same amount as A. This is directly in the middle. So we know that the x coordinate is 3. We now know that because this is symmetrical, both in the x and y axis, then from this point here on the x to the centre is also going to be 3. And then the height is going to be from the base to the top, which we were given is the value of 8. So the coordinates of B are going to be 3, 3 and 8. And that's how you would go about solving and annotating these kind of questions here. Now question number 6 is we're asked to solve this equation. So we have 3x squared plus 9x minus 2. Now we can see that this is a quadratic equation because we have the x squared, the x and then the number. Now normally what your go-to thing would be to try and solve it using a trinomial. However, there is a clue here as to what technique we would have to use. When we see things like give your answer correct to 1 decimal place or 2 decimal places or whatever the request is, that's a big hint that you need to use the quadratic formula. Now the quadratic formula we know is minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now the values of a, b and c are the coefficients in front of your quadratic. So the value of a is the number in front of the x squared, so that would be 3. We know the value of b is going to be the value in front of the x term, so that's 9. And the value of c is going to be minus 2, because we take not only the value, but we take the sign with it as well. So c becomes minus 2. Now when we deduce these values, we simply pop them into the equation. And let's see what happens. So we get minus b, so that's going to be minus 9 plus or minus the square root of 9 squared minus 4 times 3 times minus 2. And that's all going to be divided by 2 times 3. So what we'll have here is we have minus 9 plus or minus. Now the square root of the square of 9 is 81. Then it's going to be minus 4 times 3 is minus 12 multiplied by minus 2 becomes plus 24. And that will be all divided by 6. So then what we have is we'll then have minus 9 plus or minus the square root of 105 divided by 6. So when we get it to this point, what we can then do is split it up into the 2 individual calculations. So what we can say from here is, just running out of space, so I'll pop the 2 of them here. We get minus 9 plus the square root of 105 divided by 6, or we have minus 9 minus the square root of 105 over 6. So then when you perform the calculation, what we end up with is the values of 0.2 or minus 3.2. And that's how you would go about solving these kind of questions here. Now if we take a look at question 7, this is given us a triangle of x, y and z, and it's asking us to determine the size of the smallest angle within the triangle. So what we need to say here is we need to first analyse our triangle, and we need to identify what angle it's actually wanting us to find, because it doesn't actually say, find this angle or find that one. It just tells us the smallest angle. So the first thing that we'll need to do is look at each of these and determine which one is going to be the smallest. Now we can see that this one is going to be bigger than that one. But we can see that both of these angles are going to be bigger than this one, because this one is an acute angle. So this one is going to be the smallest by far compared to these two angles. So what we'll now need to do is we know that we have all 3 sides. So we need to determine which equation we're actually going to use, because we have either the sine rule or the cosine rule. Now I'm going to go back up to the formula sheet, and we're going to try and work out which one we need to use. So if we consider the sine rule, then what we would need is, obviously you would tend to neglect the c. You normally just work with a and b. So in order to use the sine rule, we need 3 pieces of information. We need to know at least one angle and at least one side. and either we're going to know the other side or the other angle. And whatever one we don't know, we can find that. So we need angles and sides. Our triangle doesn't even give us any angles, so that means we can't use the sine rule. Now the cosine rule, we have two options. We have this equation and this one. Now if we look at this one, we can see that this is to determine a side. Now we don't want to know a side, we need to know the corresponding angle. So this is the equation that we're going to have to use, because if we analyse the right hand side, we can see that in order to use this, we need to know all three sides, i.e. A, B and C. And we do know A, B and C. So what we'll do is we'll write out the general formula, and then we'll go and we'll substitute in the values. So we know that this time it will be cos Z, because it's the Z angle that we want, is going to be equal to, now it was B squared plus C squared minus A squared over 2BC. So what we'll then say is that we need to determine which one is, in fact what I'll do is I'll make this A, just to stick with the nomenclature. So we're going to call this A here. This is the angle. So like I said with the equation of the triangle, we need to be very careful in how we annotate this. So this is the value of A, so this is the angle that we want. So this means that the length directly opposite is going to be small a. And that's really, really important, because that's the one that we have to be very careful of. So we've identified that if this is the angle that we want, then the opposite side must be the lowercase a. Then these values can be interchangeable. So either one can be B, the other one can be C. So what we'll do here is we'll say this is B and we'll call this C. But you can make these any one you want. You can interchange these, no problem. So now once you've identified it, it is basically a case of substituting the values. So what we'll get is we'll have 7.2 squared plus, then we'll have 8.5 squared minus 6.3 squared divided by 2 times 7.2 times 8.5. So in doing so, we can substitute in the values into the calculator. Now what I would recommend is don't try and put this in a oneer, because the chances of making a mistake are incredibly high. So what I would suggest is working out what the top line would be and then working out what the bottom line would be. So when we put this into the calculator, what we'll end up with is, in the top line, we'll get 84.4 divided by 122.4. Now if we simplify that, that will give us, in decimal form, 0.689. Now bearing in mind that that is cos A. So here I'm just going to write this for the sake of space. So we know now that cos A equals 0.689. Now for A, we need to take cos across to the other side. Now that will go across as inverse cos, i.e. cos to the minus 1. So that would be 0.689. Now to get that on your calculator, what you need to do is press Shift and then the cos button. So when you do that, you will get a value of 46.406, and that is degrees. So that would be the value here. Now you could also round that to 46.4, or to the nearest whole number, you could have 46 degrees. Now number 8 is, it tells us that we have a traffic bollard in the shape of a cylinder with a hemisphere on top. And we're told some of the dimensions. We know that the diameter is 24 centimetres, and we know the overall height of the system is 70 centimetres. And it asks us to calculate the volume of this bollard and give your answer to 3 significant figures. So we can see that this is out of 5 marks, which means there is going to be a lot of work involved, because what we're going to do here is we're going to have to find the volume of these individual shapes, and then we'll bring them together, because this can be broken up as a composite shape, because this bollard, it comprises of a hemisphere and a cylinder. So what we'll need to do first is we'll need to find the volume of the hemisphere. So I'm going to put V and then subscript H. So subscript H will mean the volume of the hemisphere. Now what we'll do is we'll go back up to the formula sheet and we'll make a note of the formulas. So the volume of a sphere is 4 over 3 pi r cubed. And the volume of your cylinder, they don't actually give you it in this formula sheet. This is one that you will have to remember by yourself. But the formula is very, very straightforward, and we'll see that in just a second. So we now know the formula of our sphere, but we have a hemisphere. So what that means is we'll have the volume of the sphere is 4 over 3 pi r cubed. And we'll work what this is, because we now can deduce what the radius is. Because we know that from that point to that point is going to be 24. Because we're told that down here. And we can see that this is flush. So that means that the radius from that point to the outside must be 12. Or even from that point to that point will be 12. So we'll have 4 over 3 pi 12 cubed. Now what that will be is we will have to multiply this by a half, okay? Because this is the volume of the full sphere. Whereas we need to work out the volume of a hemisphere, i.e. hemisphere meaning half. So we'll multiply this by 1 over 2. Now when we put this into the calculator, that will tell us that our volume for the hemisphere, so V subscript H, is going to be 3,619.1. Now what we'll then do is we'll work out the volume of the cylinder. Now as I says, we don't get given, so we'll put V and we'll subscript C this time. We're not given directly the formula for the volume of the cylinder, but we can deduce what this is. Because if we consider what a cylinder actually is, then it's going to be a circle by a given height. So what we say here is if we work out the cross-sectional area of a circle and then multiply it by the height, i.e. the area that is taken up by in 3 dimensions, then that would give us the volume of the cylinder. So there is some manipulation though that we will need to be careful of, but we'll write down the formula first. So we'll have pi, then it will be the radius squared this time, because that's the formula for the cross-sectional area of a circle, multiplied by the height. Now you need to be very careful in what we class as the height. So the height is going to be not 70, because 70 encompasses the height of the hemisphere as well. So we need to take the radius of our hemisphere and minus it from 70, because that'll tell us what this height is, if I could draw a straight line. So what we would need to do here is we need to say that H is going to be 70 minus 12. So H, the height of the cylinder, not including the hemisphere, is 58 centimetres. So when we substitute that in to this formula, the volume for the cylinder will be pi, radius is 12 squared, multiplied by the height, which is 58. And that will give us a value of 26,238.5. So now we can work out what the total volume of this bollard is, because we will say that V total, i.e. VT, is going to be the combination of the volume of the hemisphere plus the volume of the cylinder. So we know the hemisphere was 3,619.1 plus the volume of the cylinder, which was 26,238.5. So when we add these together, we get a value of 29,857. And that will of course be centimetres cubed. Now the question here tells us explicitly 3 significant figures. So that means we have to round to 3 significant figures. So this will be 29,000, and this 5 will round, well that's 7, we'll round that to 6, and that 6 will round that to 9. So we get 29,900 centimetres cubed. So you can see there is a lot of calculations involved, but you just need to take your time and be careful of the height of the cylinder. Don't take it as 70, because the 70 is the overall height of the system. So now question number 9 tells us that we have Georgie had her roof repaired and she was charged an extra 2.5% for the late payment. So she had to pay a total of £977.85. We need to work out how much she would have saved if she would have paid on time. So this is like you can talk about this in terms of reverse percentages, or you can think of it as just standard percentages. Either way that you want, essentially this is working on the premise of percentages. Now what we need to say here is we need a relationship between the percent and the total payment. So what I'm going to say here is I'm going to have 2 columns. I'm going to have percent and I'm going to have pounds. Now the amount that she was charged would be the original amount, which would be 100%. So 100% would be how much she should have been charged. But we know that this value, the 977.85, is inclusive of a 2.5% charge. So what that means in terms of the actual percent that this bill constitutes would be 102.5%. So we can then say the relationship here is that 102.5% is equivalent to £977.85. Now we want to know what the amount that would have been paid if she paid on time, i.e. what would be 100%. So we could just put 100 here because we want to know what 100% corresponds to. So the way that we would do this is we would do 100, so we cross multiply, and then we would divide by 102.5. Or we could work this out in terms of decimals as well. Either or is acceptable. So what we would do is we would have 977.85 multiplied by 100 divided by 102.5. And that'll tell us that the amount that she would have paid would be £953, so that should be 65 pence. So now what we can say is that the amount saved would be the difference between this value and this value. So we would say that it would be 977.85 minus 953.65. So that would then tell us that the amount that she would have saved would be £23.85. So question 10 now asks us to express this quadratic in this form. So this is just simple completing the square. So what we'll say here is that to complete the square, what we'll do is we'll neglect the minus 15 to start with. And what we'll do is we'll only concentrate on the x squared plus 10x. So we'll have x squared plus 10x. And then what we'll do is we need to, because this is the part we're going to find first, the x plus p and then squared. So we can see that in the final answer, we don't have an x squared, we just have an x, and the value here doesn't contain an x. So what we need to do is we cancel out one of the x's, i.e. we divide by x. So this becomes x plus 10. Now what we then need to do is we need to half this value and then square the bracket. So we'll have x plus 5 squared. So what that tells us is that the value of p is now 5. Now in order to determine the value of q, what we need to do is multiply out this bracket and then we need to do some comparing. So what we'll do is we'll have x plus 5 times x plus 5. Now we can use FOIL in order to break this double bracket. So we'll get x squared plus 5x plus 5x plus 25. Now we'll combine these terms, so we'll get x squared plus 10x plus 25. Now what we now need to do is a good checklist, is when we've multiplied this bracket out, look at the first two terms and compare them to what we started with in the original equation. If these two terms are the same as what we started with, which they are, that means we've done it right so far. So then the value of q is going to be the original value because we haven't incorporated the minus 15. So when we incorporate this, the value of q will be the original value, which is minus 15, minus the new value, which is plus 25. So this becomes minus 15 minus 25, so q becomes minus 40. Now we need to, if we left it like this, we wouldn't get the final mark. We need to write this in this form. So the final answer is x plus 5 squared minus 40. And that's how you go about completing the square. So question number 11 gives us a diagram which shows the course of a jet ski race. And the course is indicated by markers of A, B and C. Now we know the total length of the course is 1500 metres. So B is 600 metres from A, so that's this part here. And C is 650 metres from A. Now C is due north of B. We need to determine whether or not B is due east of A. So what this means is we need to work out, well, there's two ways that you can do this. We can either use the cosine rule or we can prove it using Pythagoras. Because if it is indeed due east, then that means that we would have a right angle triangle, i.e. this would be right angled because it would be completely due east. So what we can first say here is that we know the total length of the track is 1500 metres. So we can work out the size between C and B. So the size of B to C is going to be 1500 minus 600 plus 650. So what that tells us is that this value here is going to be 250. So we can annotate this here as 250, and that'll be in metres. Now when we know all three sides and we want to prove if a triangle is indeed right angled, we have to use the converse of Pythagoras. Now for me personally, I think using the converse of Pythagoras is easier than using the cosine rule. Because the Pythagoras equation is simply c squared equals a squared plus b squared. Now if we take a minute and look at this equation, then all the converse of Pythagoras is saying is that if this equation holds, because this equation explains only right angle triangles. So essentially, if we work out what the left hand side of the equation is, and then compare it to what the right hand side equals, if they are indeed the same, then that means we have a right angle triangle. And that's all we have to do. So the only constraint really is that we ensure that we label the hypotenuse correctly, i.e. the value c. So c is going to be the hypotenuse, which will be the 650. Because remember, c is the biggest side. So we'll call this then, we'll call this A, and we can call this B. These can be interchanged. You can call this A, you can call this B, it doesn't matter. So long as you call the hypotenuse C. So now what we'll do is I'm going to split this up. I'm going to refer to the equation in two parts. So I'm going to say that the left-hand side of the equation is this part here. So this is c squared. So let's work out what c squared actually is. Because we know the length of c is 650. So we say 650 squared. So if we work this out, we see that it would be 422,500. So that's what the left-hand side of the equation equals. Now the question is, if this is indeed a right angle triangle, and therefore the A is due east from B, then this should also equal 422,500. If it doesn't, then we know that this isn't completely due east of each other. So we'll substitute in the values of A and B, and let's see what happens. So we have A squared plus B squared. So we have A squared, which will be 250 squared, plus, and then we'll have B squared, which will be 600 squared. So what we can then do is we can work out what 250 squared is first. So we work that out as 62,500. And then we would say what is 600 squared. So we would get that as 360,000. So if we add these two together, we get 422,500. So the question here now is we have proved that the left-hand side equals the right-hand side. So that means that the answer is, you need to communicate your answer here, and you would say that yes, since the left-hand side equals the right-hand side, the triangle is a right angle through the converse of Pythagoras. Now you can write whatever you want so long as you communicate that yes, the answer is or the claim is indeed correct, and that you've proved it through the converse of Pythagoras. Now question number 12 is it gives us two sectors of circles. We have a big sector and a small sector. So we can see here that ABC is the sector with centre C, and DEF is a sector of centre F. Now the sectors are mathematically similar, so that right away should give you alarm bells as to what topic this is going to be. And it says that the area of the large sector is, I'm going to write this here, is A equals 2750, and that would be centimetres squared. And it asks us to calculate the area of the small one. So what we now need to do here is this is just similar shapes. And what we need to do here is we need to determine what the relationship is between the two shapes. And we do this using the scale factor. Now, what we need to say here is we are working in area. So we need the area scale factor. But we have the relationship in terms of linearity first. So we can work out what the linear scale factor is. So that's LSF, linear scale factor, is going to be the new value divided by the old value. So the new value is the one that we want to find, i.e. this one here. So this will be 30 divided by 50. Now we can just leave that as it is. I mean, you could write that as 3 over 5, but we'll just leave it as it is there now. Now what we need to do here is we now need to work out what the area scale factor is. And that's going to be the LSF squared, because the area is in centimetres squared. So our area scale factor needs to be the linear scale factor squared. So we have 30 divided by 50 squared. So now what we can do is we can say the area of the small shape is going to be the area of the large one, which was 2,750, times the area scale factor, which is 30 over 50 squared. So when you pop that into the calculator, you will get a value of 990 centimetres squared. Now always remember the units, because sometimes you may lose an entire mark if you don't include the units. So just make sure that you check what units you're working in, and then you make sure your final answer is got the correct units. Now part B asks us to calculate the size of the angle ACB. So ACB means we need this angle here. So what this is going to be is sector area. So what we need to do here is we need the sector area formula. So we'll say that the sector area is equal to the angle. Now sometimes you can use the angle, you can write theta. So you can have the Greek letter theta that denotes an angle. But I'm just going to write angle, and that's divided by 360 times pi times r squared. Because remember, we're working in area. So we need something that brings with it the centimetres, and then we square it. So that's why we use r squared. Because the radius will be in centimetres, we square that value, that will give us centimetres squared. So what we now need to say here is that we need to work out that the area of this sector is 2,750. So we actually know what the area is. So we can replace the variables that we know, because we know what the sector area is and we know what the radius is. The only unknown here is the angle. So we can say that this would be 2,750 equals the angle divided by 360 times pi times, now the radius was 50. So that would be 50 squared. So what we can then do is we can write this in terms of the angle. So we can say the angle is going to equal 2,750 times 360, because that 360 will multiply on the other side, and we will then divide by pi times 50 squared. So when you pop that into the calculator, we will get an angle rounded to the nearest whole number of 126 degrees. So what I would tend to do is work out the top line, work out the bottom line separately, and then divide the two numbers. And that's how you would go about incorporating the sector area into a similar shapes question as well. So question 13 now gives us a straight line, but it asks us to find an expression for the gradient of the line which joins the points A, which is 6, 9, to the point B, which is 4p and 4p squared. And we need to give our answer in its simplest form. So the gradient, we need to know what the gradient formula is. So we know that m is going to be y2 minus y1 over x2 minus x1. Now what we'll do before you dive into these kinds of questions, what I would do is I would label what your points are first. So what one do you want to make the ones, and what one do you want to make the twos? So we'll call this x1, y1, and we'll call this x2, y2. So when you've labelled them, you can't get them mixed up. It makes it easy to visualise. So we now say that y2 is 4p squared minus, and y1 is 9, divided by x2, which is 4p, minus 6. Now, it asks it for in its simplest form, so by substituting in, this only counts as 1 mark. In order to get the rest of them, what we can see here is we now have algebraic fractions. So the algebraic fractions, we require some factorisation. And we can see that this, the numerator, is a difference of 2 squares, because we have 4p squared minus 9. So we have the two values, the exact same thing that will multiply together to give you 4p squared, would be 2p plus, and then 3, bracket 2p minus 3. Remember, the difference of 2 squares is the only factorisation that you can assume one bracket is plus, the other one is minus. Then on the denominator, we have a common factor of 2. So we can take 2 out, and that will give us 2p minus 3. Now that's not in its simplest form, because we can see that we have a bracket of 2p minus 3 on the top and the bottom. So we can cancel them out, and your final answer will be 2p plus 3 divided by 2. And that's how you would go about solving the gradient incorporation of algebraic fractions. Now, question 14 is a trig equations question, and it asks us to solve for the values of x between the conditions of 0 and 360 degrees. So the first thing to do is write out the equation that it gives us. Plus 2 equals 1. Now we need to rearrange this for cos x. So the first thing we'll do is bring the plus 2 across. So if it's plus 2 on this side, it's going to go over as minus. So we get 5 cos x equals 1 minus 2, which is minus 1. Now we'll need to get rid of the 5, so the 5 is multiplying the cos x, so we'll divide it by 5. So we get cos x equals minus a fifth. So now what we need to do is, in order to find the value of x, we need to bring the cos across. Now that, again, remember from the previous questions, is that this will go over as inverse. So x will equal cos to the minus 1 of minus a fifth. And that'll tell us that x equals 101.53. So then what we need to do is we turn our attention to a cast diagram, because we now need to work out, do we have any other values that will fit within the condition of 0 and 360. So we're using cos, and we see that the angle that we've created is positive. So what that means is that we now need to work out which quadrants we're going to tick. So because the value is positive, we're going to tick the A quadrant and we're going to tick the C quadrant, which means the calculation for the C quadrant is going to be that x equals 360 minus the angle. And we know what the angle is, that's going to be 101.53. So x equals 360 minus 101.53. So x is going to equal 258.46 degrees. So that is the two valid solutions for that question there. Then question 15 is, we now need to basically combine these two algebraic fractions and simplify as far as possible. So what we have here is, we will perform, because we're taking fractions away, so we need to do the kiss and smile method. So that means that we will cross multiply, and then we'll multiply the two denominators together. And what I'm going to do is I'm going to put the denominators in brackets. So what we'll end up with is we'll have 4 bracket x plus 5 minus 3 bracket x minus 2. And that's all going to be divided by x minus 2 multiplied by x plus 5. So there is no need just now to multiply this out, because that is it technically in its simplest form, because if we multiply this out, we would have to put it back into the two brackets. So all we now need to do is multiply out these brackets on the top and collect the like terms. So here we get 4x plus 20 minus 3x plus 6. Because minus 3 times minus 2 will give us plus 6. And that will all be divided by x minus 2, x plus 5. So then when we simplify this, we'll collect the like terms. So we have 4x minus 3x is x. Then 20 plus 6 will be 26. All divided by x minus 2, x plus 5. And that is it in its simplest form. Then question 16 is we have some surds. So what we need to do here is simplify as far as possible. So we just need to be very careful as to how we solve this, because there is some pre-manipulation that we need to do first. So what I would do is I would rewrite what the square root of 8 is as a power. So we know that the square root of 8 is going to be a to the power a half. And this is going to make it easier in order to solve the indices. So now we can put a to the power 4 times 3a divided by a to the power half. Now we have two manipulations that we need to carry out. We need to combine the top line and then we need to divide. Now what I would suggest is combine the top line first so that you have a single term, and then we will solve the division. So a to the power 4 times 3a will give us 3a to the power. Now remember, when we multiply terms, we add the indices, and this a brings with it the power 1. So this becomes 3a to the power 5 divided by a to the power a half. So now when we divide this, we now need to say that we're going to have 3a to the power 5 divided by a to the power a half. So when we do this, this is going to be 5 minus a half. So at the side here, we'll do 5 minus a half. Because remember, it's the top, take away the bottom. And what we'll do is we'll put this over 1 to turn it into a fraction. And we know that when we take fractions away, we need to make the denominators the same. So we'll just multiply this fraction by 2. So that gives us 10 over 2 minus a half. So then we'll do 10 minus 1, which is 9 over 2. So that tells us that our final answer is going to be 3a to the power 9 over 2. Now you can be very fancy if you want, and we could rewrite this as 3, the square root, because that's the root, of a to the power 9. That is it in its absolutely most simplest form possible. But here, this, you could leave it as this and you would still get the 3 marks. But if you want brownie points, you could write it in terms of a surd if you wanted. Now question 17 is we need to expand and simplify this trig expression. So we have, essentially what this is it's going to be breaking double brackets. But instead of having just x's, we're now going to have it in terms of trigonometric functions. So we'll rewrite this, because this is squared, we'll rewrite this as sin x plus cos x bracket sin x plus cos x. Now we'll apply FOIL to these brackets. So we'll have sin x times sin x, which gives you sin x squared plus sin x cos x, because that's sin x times cos x, plus cos x times sin x, then plus cos x squared. So now what we can see here is I'm going to rewrite this as sin x, just so as that we can see that these are exactly the same thing. So we actually have 2 of these. So we can write this as sin x squared plus 2 sine x cos x plus cos x squared. Now, the final simplification comes from the knowledge that we know this relationship. And I'll write the relationship up here. That we know that sine x squared plus cos x squared will equal 1. So we know that we have sine x squared plus cos x squared. So our final answer, we can replace both of these with 1. So the final answer becomes 1 plus 2 sine x cos x. And that's a very tricky question, especially knowing that these are exactly the same and identifying that the sine x squared and cos x squared, they will simplify to 1. And then finally, question 18 is one that caused significant problems in the 2019 exam. So we'll go through this and we'll see how to solve this one with ease. So we have a cartoon snowman and it can be represented by 2 circles. And we know here that the head is a small circle with centre S and it has a diameter of 15 centimetres. So from that point there to that point there is 15. Now the body is part of a larger circle with centre T, and the point T lies on the circumference of the smaller circle. We can see that here. And points A and B lie on the circumference of both of the circles. And we need to calculate the value of CD, the height of the snowman. So right off the bat, what we can say here is that we know the height from C to T. We know this has to be 15 because that's the diameter of the system. So we can see that our snowman is going to be 15 plus the value of TD. Now this is an incredibly difficult problem solving question because what we now need to try and identify here is some correlation between the 2 circles. And a lot of the time these complicated problems involve the idea of Pythagoras. So what we now need to say here is the following expression will apply. Now if we draw or try and attempt to find concurrency in terms of the radius between here and here, because we know that point A lies on the circumference of both circles. So we can say here that AT is going to be the radius of the larger circle because we need the radius. That's what TD actually is. That's the radius of the big circle. So we can now create a triangle using the small circle that will give us the relationship that we need that would correspond to the big circle. So this is the triangle that we're actually going to work with. So if I write this triangle like this, what we can see here is this is, say, R, because this is the value of, or in fact what we could call it is TD, because that's this length essentially, because this is going to be the longest side in a triangle for a circle is the radius, because we can't get any bigger than that from the centre to the outside. So we need to find this value here. Now we know this length. This is half the diameter. So this becomes 7.5. And this is exactly the same. So this would also be 7.5. So that means that in order to determine TD, we would say that TD equals, or in fact we'll use the C squared equals A squared plus B squared. We'll do it the proper way and we'll label our triangle. So we know that TD has to be the hypotenuse C, and we can call this A and we can call this B. It really doesn't matter because they are exactly the same. So what we now say is that TD squared will equal 7.5 squared plus 7.5 squared. So TD squared is going to equal 112.5. So that means that TD is going to be the square root of that value, which is going to give us a value of 10.6. Now that means that the radius of the big circle, i.e. TD, is 10.6. So that means the total height is going to be, so we say that the total height is going to be the 15 from the small circle plus the 10.6 from the bigger circle. So that tells us that the value is going to be 25.6 centimetres high. Now question 19 gives us, I think this is the last question. It says that Katie and Monica are looking at a hot air balloon, and in the diagram below, K, M and B represent the position of Katie, Mona and the balloon respectively. The angle of elevation of the balloon from Katie is 52 degrees and then from Mona is 34 degrees. Now both of them are 350 metres apart. We need to calculate the height of the hot air balloon. So that means we need to calculate this value here. So it's 5 marks. It's going to be the last question. So that means that we're going to have a considerable amount of work required. Now the first thing that we'll do is we need to work out the other angle, potentially, of the system. So what we can work out here is we can work out this length here. Okay? So what I would do is we will use the sine rule and we will work out what this value is here. So we're going to work out what the BK value is. So BK. You could also work out what BM is and you would still get the same answer regardless. Now what we can then say here is that we'll use the sine rule. So that's going to be A over sine capital A equals B over sine capital B. Now we'll label our diagram. So we'll say that in order for this to work, we will make BK small a, which means capital A must be 34, and we'll then say that small b will be this value, which is 350, but the problem still lies is we don't know what this is. So we have to do a second calculation first. We need to work out what this angle is, so this is capital B. So in order to do that, we need to do 180 degrees minus 52 plus 34. Because we know that the total angle in a triangle adds up to 180. So the difference between them is going to give us a value of 94 degrees. So in here, this is 94. So this gives us capital B. So what we can now do here is we'll substitute in our variables and rearrange to get the value of BK. So we'll have BK over sine 34 equals 350 divided by sine 94. So what that means is the equation for BK will be 350 times sine 34 divided by sine 94. Now if you pop that into the calculator, we will get a value of 196.195. So that tells us that the distance from here to here is 196.195. Now what we need to do here is we now need to do it again, because we now know enough information that we can work out the height of this triangle. Because, let's draw this again, and we'll annotate our new triangle. So we'll draw this in orange. So this is the system. In fact, that is a very bad triangle. I'll just delete that. So this is the triangle that we want. This is the height that we need. This is what we're trying to find. This is the height of B, because this is K and this is B. Now we've just worked out that this is 196.195. We know this value here is 52. We know this is 90 degrees because we've now created a right angle triangle. So what this now means is that we know this side is directly across from 90 degrees. We have the unknown side directly across from a known angle. That means we need to use the sine rule again in order to determine the value of h. So let's use the sine rule again. So A over sine capital A equals B sine capital B. So remember, this is the last question, so this is designed to be hard. So we will annotate this one. So we'll say that this is small a. Oops, I'll put this a different colour. So we'll say that this is small a. Then 52 degrees is, small capital A. Then the 90 will be capital B. And this will be lowercase b, the 196.195. So when we pop this in, we will get h over sine 52 is equal to, then what was it? It was 196.195 divided by sine 90. So that means h will be 196.195 multiplied by sine 52, all divided by sine 90, which is an exact value. So when you pop all that into the calculator, you will get a value of 154.6 meters. So that tells us that this height here is 154.6 meters high. And that's how you would go about solving that question there. So that's the end of the 2019 calculator paper. I hope you found this helpful. Please leave any comments that you found helpful on this video, and please consider liking and subscribing to the channel. It really helps us reach as many students as possible. Thank you for your time, and we hope to see you in another tutorial.